Hello again and welcome to class. It's another Python class, and today we will be examining lists in Python. So this is the third Python class this week. This is the third Python class this week, and we will be examining lists as a continuation of loops and lists, which we are considering this week. It's week 3. So what is a list in Python? So a list is an ordered collection of items, right? A list is an ordered collection of items, meaning that we put several items together but ordered, meaning that each of them they have we can arrange, they are arranged, right? This is the first one, second, third, and fourth. So a list can contain any data type. It can contain integers, strings, boolean, even other lists. Other lists can be in it. So lists are contained inside square brackets in Python like this. So they are contained in square brackets in Python like this. Right. So lists can be stored in a variable, right? So you can say my list equals, then you have A, B, C, and D. So this is a string. You notice that I separated each item in the list with commas. So we separate each item in a list with commas. Alright, so and remember, list can contain any data type. So I can add number, can add integers here, I can add a float, and I can add a boolean. Alright, so that's it. If you try printing a list, it will just print it plainly like that, as a list as it is. Just gonna print it plainly like that. Alright, so you have it. That's just how it's going to print. It's going to print it plainly like that. Alright. So we need to it's important that we note that each item in a list are ordered, right? They are ordered, and there's what we call indexing. Now indexing means we try to access a different positions in a list, and in a list the indexing starts from 0 like this: 0, 1, 2, 3. So the first item is index 0, the second one is 1, the third one is 2, 3, like that. All right. Now if I have the list I created earlier, where is that list? Alright, in this list now, if I want to get the first item, then I'll use this. This is how we get it. My list then this square bracket 0. Now this my list with square bracket 0, it's going to get the first item in the list. It's going to guess the first item in the list. So if I print this, so it gives me A, because A is the first item in the list. If I replace this with maybe 1, if I replace it with 1, then I'll get, let me close this, let me rerun it. gives me B. It gives me B because B is the second item in the list. So lists are numbered 0, 1, 2, like that. That's how we index it. Now, if you want to index the last item in the list, if you want to take the last item in the list, let's say you have a very long list and you don't know what position the last item is, then it will be minus 1. Minus 1. So let's try that. So it gives me true, which is the last item in the list. So if you start minus 1, we start from the back. So minus 1, minus 2 will give 2.5, and so on and so forth. So that is how you index lists. That's how you index lists. So there are also many other things we can do with lists. Like we can add item to a list. We can add item to a list. For instance, now I can say my list dot append. Now this append is used to add items to the end of a list. So if I say my list dot append Lawrence, meaning that I want to add the string Lawrence. So once I say my list dot append Lawrence, let me now reprint it. Let me print the list now, and let's see what we get. Let's see what we get. Alright, so now you see that we have A, B, C, D, 1, 2, 2.5 through, then we have Lawrence appended to it. So append adds to the list from the back. It starts from the back. Right? That's from the back. So the next thing we want to do is remove. So when you use my list dot remove like this, this is how you write it, my list dot remove. Then in brackets you put what you want to remove. So my list dot remove Lawrence, the one I just added. No, I'm not going to do that. You know, at this point I have not added Lawrence, right? So or you know what, let me keep the append, then let me now remove. This is what I'm going to do. I will print the list after appending Lawrence, then I will remove Lawrence and reprint it, so that we have two different printing. My list dot remove. No, instead of Lawrence, let me remove something else. Remove true. Now true is not a string in it. But what if I try putting it like this? Let's see what we're gonna get. Probably that should throw an error, because this string does not exist in this list. Okay, so I'm printing my list again. So let me run that. Okay, now you see that it first prints. Let me just reduce this a bit. Now you see that you see that we first have my list printed, right? And then it threw an error here because this true does not exist in the list. It says list dot remove x not in the list, meaning that this string called true is not in the list. The true in the list is a boolean, so it doesn't recognize it. So what if I change this to a boolean, the boolean true? Let me rerun this. So you see that it gets printed. Okay. that only removes one. So but of course you can try removing something like Lawrence, or let's remove A from the list. Let's see how that will go. Alright, so you see that A does not exist anymore. That means the way it works for Boolean is different. Alright. So now let's talk about pop. Now it is possible to pop an item in a list. And what does it mean to pop an item in a list? To pop an item in a list means to remove the last item in the list. That's just what it means. To remove the last item in the list. Right? You say my list dot pop. Now print my list. No, I'm not putting this. So you can see that it has removed the last item, which is true, right? It has removed it. It is possible for you to print what you popped, right? It is possible for you to print what you popped. So you can say popped item equals my list dot pop. So print popped item. You see? So you can store what you popped. So I popped true, and I stored it in this variable called popped item. So you can pop item like that. Store. So what's the next operation we want to talk about? So the next operation is sort. So it is possible to arrange the items in a list. It is possible to arrange the items in a list. Now let me have another list. Now let me say fruits equals. I'm not going to arrange it orderly. Let me just say orange, banana, mango, what else pear. Is it pear or pear? Which other fruit do we have there? We have a coconut. All right, so remember, you don't put comma at after the last item unless you want to add something else. So you don't put comma like that. All right, so what I want to do is I want to sort this list. This is how we have it here, but we can sort it. So we're going to say fruits dot sort. Okay, print fruits. So once I've sorted it, it says banana, coconut, mango, orange, pear. So it has sorted it, it has arranged it alphabetical orderly. So it has arranged it alphabetical order. So let's see if we have some integers in between here. Let's see if we have some integers in between. Let's have 2 here. Let's have 5 here. put comma here, so let's have another one here. Let's have 3 here, and let us see what happens. I'm thinking alphabetical. I'm thinking the alphabet should come first, but let's see what happens. Okay, not supported between instances of int and string. Alright. So what happens is that Python does not support sorting a list of numbers and letters together like that. So unless you have only numbers in the list. So let's say we have another list, numbers equals, then you have 5, 6, 2, 3, 1. So instead of fruits, let's sort numbers dot sort, and then we're going to print numbers. So let me clear this terminal first, let me rerun. Alright, so it sorts it. Alright, so it can work with numbers, and then it can work with strings like that. So it is possible for us to reverse a list also. It is possible for us to reverse a list. Alright, so instead of numbers dot sort, let's say numbers dot reverse, and let's print numbers and see what happens. Alright, so reverse means it takes the numbers from the last 1, 3, 2, 6, 5, regardless of the ordering, regardless of whether ascending order or descending order. So it takes it from the back and rearranges it. That's just what reverse does. So the next one we're going to talk about is index. So index is used to find the position of an item in a list. So let me remove these numbers. Let me now index. So index. Okay. So the way we use it is fruits dot index. Now write the particular element you want to index. Let me index pair now. Pair, meaning that I want to find the position of pair. So let me print it. So let me print the index of pair. Okay, so if you take a look at this, it gives us 6. It returns 6. So meaning the position of pair is 6. 0, 1, 2, 3, 4, 5, 6. So that is how you index. That's how you get the index of a list. So it's possible to get the index of a list. So it is possible for us to count also. Counting means to check how many times something occurs in a list. For instance, if I say print fruits dot count orange, let me close the second bracket. So let me run this. So it gives 1, it returns 1. What if I have another orange here? What if I have another orange here? So it gives 2. It gives 2. It gives 2. So meaning that there are 2 oranges here. There are 2 oranges here. So that is how count works. Now, the last operation I'm going to mention is learn. The learn operation. Now you can know more about this. You can go to W3 schools, or you check out our ebooks like the one dropped on the group earlier. So to know about all the operations that could be done performed on lists. So we can print learn, the length of a list. So if I print learn fruits, I want to get the length of these fruits. I want to get how many items are there. How many items are there? So it gives 9. It returns 9 because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now don't forget that the index starts from 0, right? So if you want to index, the last item here will be what? Will be 8. So if I print fruits with this bracket, if I try to print fruits 9, because we have 9 items, if I try to print fruits 9 with the index of 9, you see that we have an error. It said list index out of range, meaning that we are out of this list, we have gone out. But if I try to get the 8th item here, so it gives orange. It gives orange, meaning that there are 9 items here, but it is indexed as 0, 1, 2, 3, 4, 5, 6, 7, 8. That's how it is indexed. So that is all about that's all we learned about lists today. You can play around with it, and then you can use it in your assignments for this week. Use it for your assignments in this week. But just before we conclude today, we are going to right now we are going to look through lists. We're going to see how we can look through lists. So the easiest way to look through lists is using for loops. For loops. All right. So let me just return this my list here. Just return my list here. So the first thing we are going to do is we are going to use for loops to iterate through everything here. First, I want to remove these numbers. I want to remove the numbers. Alright, so we have no numbers. I also want to remove this last orange here. It was just a test. Alright. So we want to use a for loop here. So we're going to say for. Remember, to use a for loop now, you need an iterator. You need a variable to use for iteration. First, let me clear this terminal. So I'm going to say for fruits. For fruits in fruits. So for fruits in fruits, meaning that pick each fruit in fruits one at a time. Right? We are going to do it the number of times the number of times we have fruits here. Like we have 1, 2, 3, 4, 5. So we are going to do it 5 times. For each time we take one fruit. For fruits in fruits, we say print. I'm going to print f. Use the formatted printing. Print f. I like. Then you have this curly brackets. I like fruit. No, I like fruit. Right? We are injecting this variable into it. I like fruit. So let's run this and see what we get. So as you can see, it takes each of these fruits one after the other. I like orange, I like banana, I like mango, I like pear, I like coconut. So that is how a for loop works. We learned that earlier. It takes each item one at a time, and because we we use this float as the variable to name each item temporarily. So that's what it does. So then I want us to do something like a little mathematics here. Let's say score equals 50, 40, 28, 36, 78. So let's say total equals to 0, right? Then for score in scores, oh sorry, this has to be scores because this contains all the scores. So for score in scores, meaning that we are taking each score, we are going to say total equals to total plus score. So what does this mean? It means first we have a variable called total, right? Then we are now going to say for score in scores, meaning that take each score and begin to add it to total and change the value of the variable total after adding it. So now we are going to print total. Okay, all right, so now I don't want to do this. Now the reason why it prints it like this, what it's doing here is that it says, okay, for score in scores, meaning that each time it takes a score, add it to the total, then it will now print the output. If you want it to just print the total all at once, so not print it repetitively. If you want to print the total one time only, then you will not put it inside this for loop. You bring it outside of this for loop. You know this for loop starts here and ends here, but if this place is indented, if this print is indented, then it means that this print is under this for loop. Let's exit the for loop. So let's see what that gets us. So it gives us 2, 3, 2. That's the sum total of all these scores. That's the sum total of all the scores. So let me do something else here. For score in scores, okay, let me have a variable called passing equals to 0, or let me say passed equals to 0 to mean the number of students that passed. So for score in scores, I want to say that if a score is greater than or equal to 70, then the student passed. For score in score, if score greater than equals to 70, then we say passed plus, so we say this passed equals to passed plus plus 1. Now, meaning that if a score is greater than or equal to 70, then we increase this pass by 1, right? We increase this pass by 1. So now let's exit this and print f number of students or number of passing scores equals, then we inject this passed. We want to see number of passing scores. So number of passing scores is 1 because only one score is greater than 70, is greater than or equal to 70. Let's say we have something like 80 here, and we have like 75 here. Then we should know that the passing score would now be more than 1. So number of passing scores is now what? 3, because for each of these, every time those that passed is equal to 0 currently, but then from here it begins to take each score. Okay, 50. Is 50 greater than or equal to 70? No, then it will not execute this. Remember that if statement will execute only if the condition is true. So if this condition is false, it will skip it. Then it will go back to this one again, because we are looping, because for loop iterates through everything. So it will go back to for loop again. Okay, let's take 40 again. Is 40 greater than or equal to 70? No, it's not. Then it goes back to the for loop again, takes 80. So 80 is greater than 70, is greater than equal to 70. So then we can count 80 as a passing score. So we increase the number of passed to 1. So it goes again 28 until it gets to the last one. So while going through this, while iterating through this, we have 80, 75, and 78. Those are the scores that passed. So that's why we have 3 passing scores total. So this brings us to the end of our lists and to the end of week 3 lessons. So we wish you good luck in your assignments for this week. So see you next week.